Build an LLM app that remembers, searches your documents, uses tools, and returns grounded answers with LangChain. Let's begin with build more than a chatbot. LangChain helps turn a language model call into an application with prompts, structured results, memory, retrieval, and tools. Our working project is a personal knowledge assistant that answers questions from private documents and can call a calculator when needed. A plain model knows only the messages and context sent in the current request. The application layer decides what context to add, what action to allow, and what result format the software expects. That separation matters because useful assistants need predictable behavior, not only fluent text. By the end, you will understand each building block and how they connect in one testable workflow. That sets up the architecture before the code. A user question first enters the application, not the model directly. The prompt layer adds instructions and relevant input in a controlled format. Retrieval can fetch useful passages from your files before the model answers. Memory restores the correct conversation thread without mixing different users. An agent can choose a permitted tool, observe its result, and continue until it can answer. An output schema turns the final response into data that downstream software can validate and use. Langsmith tracing is optional for the demo, but it becomes important when several model and tool calls interact. That idea leads directly to project setup and assumptions. This tutorial uses Python 3.11 or newer, a virtual environment, and the current LangChain packages. Install the core framework, the OpenAI integration, text splitters, PDF support, and environment variable loading. Keep the API key in a local .env file and never commit it to source control. The project separates model logic, retrieval, memory, agents, and tests so each idea stays visible. We use an in-memory vector store and checkpointer for learning. Production systems need durable, access-controlled storage. A successful setup ends with imports resolving and the model key being available at runtime. That idea leads directly to models, one interface, many providers. The model is the reasoning and generation engine, while LangChain provides a consistent application interface around it. Init.ChatMo lets the application select a supported provider model through configuration rather than scattered provider-specific code. The input is a sequence of messages, the output is an AI message with text and useful metadata. Temperature and model choice affect behavior, cost, latency, and repeatability, so they belong in configuration. Start with one small request and print only the returned content to verify credentials and connectivity. Model abstraction makes swapping providers easier, but it does not make different models behave identically. Once models, one interface, many providers is clear, prompts, instructions as application logic becomes much easier to understand. A prompt template separates stable instructions from values supplied at runtime. In our assistant, the system message defines the role and evidence rule, while the human message carries the actual question. Named variables make the contract visible. The application must provide both context and question. This is safer and easier to test than building one large prompt with string concatenation. Good prompts specify the task, constraints, available evidence, and expected response behavior. The key insight is that a prompt is versioned application logic, not a magic paragraph hidden inside the code. From there, the next practical step is parsers and structured output. Freeform prose is useful for people but fragile for software that expects fields such as answer, confidence, and sources. A pydantic schema states the shape and types the application needs. The model is configured for structured output, and LangChain returns a validated object instead of text that must be guessed apart. The input remains a normal user request, but the output can feed a UI, workflow, or database reliably. Validation failures should be logged and handled. Structured output reduces ambiguity but does not remove the need for error handling. Use a parser or schema when another component will consume the answer programmatically. This sets up the next important point, chains, a controlled sequence. A chain is useful when the order of operations is known in advance. The pipe operator connects compatible steps, prompt output becomes model input, and model output becomes parser input. Each stage has one responsibility, which makes the data flow easier to inspect and test. Our summary chain receives raw notes, asks for 3 concise bullets, and returns plain text. Unlike an agent, this workflow does not decide which step comes next, the developer already defined the path. Choose a chain for predictable transformations and an agent only when dynamic tool selection adds real value. Choose a chain for predictable transformations and an agent only when dynamic tool selection adds real value. That sets up memory, state belongs to a thread. Memory is not the model learning permanently, it is application state restored for the right conversation. A checkpointer saves agent state, while thread_ID identifies which conversation should continue. Two calls with the same thread can refer back to earlier messages. A different thread starts without that history, preventing accidental conversation crossover. Long histories still need trimming or summarization because context windows, latency, and attention are limited. In-memory storage is ideal for a demo, but a production assistant needs durable storage, retention rules, and user-level isolation. Once memory state belongs to a thread is clear, prepare your documents for retrieval becomes much easier to understand. Question answering over private data begins by loading documents into a common document format. Large files are split into overlapping chunks because entire document collections rarely fit into one model request. Embeddings convert each chunk into numbers that represent semantic meaning. A vector store keeps those embeddings so similar passages can be found from a natural language question. Chunk size and overlap affect retrieval quality, tiny chunks lose context, while huge chunks introduce noise. Metadata such as file name and page number should travel with each chunk so the final answer can cite its evidence. From there, the next practical step is retrieve first, then generate. At question time, the retriever searches the vector store for the most relevant chunks. Those passages become context in the answer prompt, they do not retrain the model. The model is instructed to use the supplied evidence and admit when the evidence is insufficient. This two-step RAG pattern is predictable because retrieval happens before generation every time. Print the retrieved text and source metadata during testing, not only the polished final answer. A convincing answer with irrelevant evidence is still a failed retrieval system. Once retrieve first, then generate is clear, agents, let the model choose a tool becomes much easier to understand. An agent combines a model with a harness that exposes instructions, tools, state, and runtime controls. A tool is a normal function with a clear name, typed inputs, and a description that tells the model when it is useful. For a calculation question, the model requests the calculator, receives the tool result, and then writes the final response. The loop continues until the model has enough information or reaches a configured limit. Tool descriptions are part of the control surface, vague descriptions can produce the wrong tool choice. Agents are powerful because the path is dynamic, but every permitted action expands the system's risk boundary. With agents, let the model choose a tool in mind, the next piece is combine retrieval, memory, and tools. The complete assistant exposes document search as a tool and preserves each conversation with a checkpointer. A policy question can trigger retrieval, while a numerical follow-up can trigger calculation. The model sees the current request, relevant thread history, available tool definitions, and returned observations. This is different from a fixed RAG chain, the agent decides whether retrieval is necessary. Keep the tool set small and purpose-specific so the decision remains understandable. The finished workflow is a personal assistant pattern, private knowledge, conversational continuity, and controlled actions. That idea leads directly to test what the user actually experiences. A useful test checks behavior, not merely whether the code runs without an exception. Ask a grounded question and confirm the answer is supported by one of the retrieved passages. Ask a follow-up in the same thread to verify conversational continuity. Repeat it in a new thread to confirm that private context does not leak across sessions. Test an unsupported question and expect the assistant to say that the documents do not contain the answer. Record retrieved chunks, tool calls, latency, token use, and failures so regressions become visible. Record retrieved chunks, tool calls, latency, token use, and failures so regressions become visible. That sets up common failures and fast fixes. If imports fail, check the current integration packages instead of copying an old monolithic LangChain installation command. If retrieval looks unrelated, inspect chunks, metadata, and similarity results before changing the prompt. If memory appears broken, verify that a checkpointer exists and the same thread_ID is reused. If an agent skips or misuses a tool, improve its description and reduce overlapping tools. If answers sound certain without evidence, strengthen the grounding rule and return citations alongside the answer. Most failures become diagnosable when each model call, retrieved passage, tool request, and tool result is traceable. From there, the next practical step is production safety and the next step. The demo proves the architecture, but production requires authentication, authorization, encryption, and secrets management. Treat retrieved documents and tool outputs as untrusted input because they may contain prompt injection instructions. Give tools the least privilege possible and require human approval before sensitive writes, payments, deletion, or external messages. Replace in-memory stores with durable systems that enforce tenant isolation, retention, and deletion policies. Add evaluations for groundedness, retrieval relevance, tool correctness, latency, and cost before scaling traffic. You now have the core pattern, controlled prompts, structured results, deterministic chains, thread memory, retrieval, and agent tools. A strong next improvement is to add source citations and human approval, then trace the full workflow with LangSmith. To wrap up, here is the key takeaway. You now have a structured overview of LangChain tutorial. Build an LLM app with RAG, memory and agents. Review the core ideas, connect them to examples, and revisit concepts like build more than a chatbot, the architecture before the code, project setup and assumptions when practicing. Subscribe to Easy Machine Learning Guide if you want to learn AI through simple explanations and real industry examples.